Hello everybody, welcome back to From Rhythm to Algorithm, picking up the last episode I just titled Most of Physics, because in trying to derive it from first principle, intuitively I feel like a lot of shit's going on, so I'm just trying to capture any insight that I can. Obviously, if I say anything that's objectively wrong, it's objectively wrong. But this video is filmed pretty much not immediately after, but I mean, you can see the timestamps. But I wrote some theorems down pretty much just immediately after, but I did not watch the previous episode whatsoever. But again, right, we all start with physical intuitions because you're born into the physical world and trying to build up the mathematical model of language or language. The last episode did that. So we're in this world with words and we're trying to again derive the biggest, so like just trying to get the biggest pieces of theory, not of theory. So this is again mathematical proof. Proof establishes a fact. So everything we talked about before, right, that's physics, right, is literally an iteration of is. And so words have meaning. You can't reduce things past a certain level. Try to give you as much insight into those phase changes as possible. But the things just going through again in order, what then came to me is like what I felt like I didn't cover enough. But variables. And so with mathematics, once you get numbers, right, then you have, right, what is a number representing? And then numbers more to a constant or a scalar, but all right, you have the concept in the application of variability, right? All of these physical systems we're representing, so we have variables. And then how do variables relate? And then, right, sets and categories is kind of like the limitation of variability, right? 3 things, 3 apples, 3 trees, 3 whatever number to, indicates how many elements in that set. And then set, logically, is set. We had a whole episode on that. But the concept of variables, things change. Went through ordinality, we've completed ordinality, and we had just, again, cardinalities to magnitude. And so sensorality variates. But another big thing is how those sets with the minimum foundation of 2. We'll get to that here in a second. But just overall rates of change. How does one thing with all of its internal properties relate to another independent system with its internal properties in a collective outward environment? And so rates of change, calculus is it sounds kind of weird to say obviously, but it's a very, very good derivation. It's just whenever this antiderivative stuff, that's the only verbiage that I even have to like change. But I've rederived calculus, but it's pretty good as is what I'm saying. But the antiderivative, that's just absolute nonsense from the get-go. The rating change, we'll get to change here a little more specifically. But the big kind of physical thing we left off of, again, and I wrote this immediately after and I have not watched the last episode, because you'll see there's no editing on the bottom. But what is a magnet? Like physically, what is it? When you have, right, the operative words polarity, positive, negative, right? What is this relationship between charge and magnets? Right, there are independent charge. The electron can be separated. The proton can be separated. You can have a chunk of thing net negative. You can have a chunk of thing net positive. But magnets cannot be broken down. And so you have polarity. That's the right word. And it's positive and negative. Those are the right words. So is that stabilized charge? Right, a moving charge induces a magnetic field, and we talked about that last time. I'm very confident. The physical empirical fact is there are no magnetic monopoles. And the historical people trying to do that is like, again, trying to prove a double negative or, it's like the things that are definitely not possible, people really try to do. And it's just like, that's like, beating a dead horse, or there's a phrase for it. And so to me, magnetics are foundational. What foundational meaning? Stabilized. That is the physical thing. It's a dynamic. There's 2 components, and it's positive and negative. So why that has to be charged to me? But that would mean charge is discrete, and it is discrete, right? You have the conservation of charge is articulated through quantum jerk-off theory all of the time. But again, then why? Again, I just don't know why you wouldn't be able to break down a magnet. And it just has to be a physical limit then. But to me, that's what a magnet is stabilized charge, that positive and negative. It's still mass, like it's still physical thing. The electron definitely has internal dynamic, but it's just that stabilized thing of two and then some sort of physical limit of the electron acting as a point particle is good enough. And so, because mass is definitely the discrete thing, saying energy levels doesn't really make sense, but it's so close where it's like the logical nuance is pretty much irrelevant. But I want to say that's what a magnet is stabilized charge. And then what is charge? Again, it's just like age iterated with some consonants. But just a discrete property, a discrete internal disparity, a discrete difference. The discrete difference is what I would say charge is. So again, I think charge is the foundational thing you can't intuitively break down anymore. But then a magnet just being that charge stabilized dynamic. But regardless, this last time again I balked at the word energy, or not energy, gravity. And again, I haven't watched it, but just again, it was like an hour long. It's like the longest derivation I've ever done. Again, to continue. I mean, there's no point. I'm gonna just again the ending words are what matters, but I'm trying to give you again as much intuition as possible. But these magnets, again, gravity is not a force. It's not a shape. It's more of it's a linguistic form of vibration, like vitality, the gravitation, vitation. And so it's just one of those words where it's like even now I like chirality better than gravity. But to me chirality is more well defined. We kind of hit that naturally last episode. But the point being is tension. You have magnets and you have them in a geometry, which is an environment where you can't line up perfectly, right? You can see people, this big not social phenomenon, but a lot of people like those hexagonal, like lighting, but like the discrete hexagons lining up to one another. But right in 3 dimensions, everything they don't line up perfectly. And so you have tension, right? And that's the big physical property I didn't say last time, was geometry interacting, mass with geometry. Mass creates geometry, but interacting creates tension. And tension is disparity or discrepancy from equilibrium. Equilibrium is a dynamic, and this property charge is the inherent property, I want to say. Again, I could be flat out wrong or missing something still, and fill in the blanks or whatever. But then stabilized charge forming a magnet that is physically irreducible. You can localize charge. That's what we see in the. But again, that's why you have. That's what. And then I want to keep that there. But and then the magnets, again, because of the geometry shape, the way common people have articulated, it's fine. But then you just have tension, right? And you can't have a state of zero tension, meaning, right, because of this geometry, a triangle, that whole argument or reality, things are always vibrating. You can't have zero temperature. You can't get to zero. Zero doesn't represent anything. And so tension is always trying to, right, how does tension relate to this inversion relationship between entropy and energy? Right, so a system that is tense, right, has the capacity, right, energy is the capacity to do work. A tensed system has the ability, or is going to want, or to tend to return to equilibrium, which is this dynamic stability state thing. And so just trying to again articulate why tension replaces potential energy, because it's just a logical difference. It's definitely, potential energy is definitely doesn't make any sense, but again, we have to go into high school and rewrite this for the high schooler? I mean, sure. I mean, again, because it doesn't change anything numerically, but I'm showing you where this, right, tension is at odds, but tension is energetic, is a connecting thing, right? If you go to a bar or a sports game and there's a lot of tension, right? People are on edge, they're energetic. So tension is energetic. It's a logical theorem. But again, you can't really, when something's not defined properly, potential energy, it's just you just have to separate those two concepts into potential. and then energy, which is the potential to do work. So they're intertwined, so I might be able to clean that up a little bit more. The point being is this: you have systems, there's always a state of tension, meaning a system is trying to return to equilibrium. So you always have movement. Another big concept, right? Words have meaning, the mean, median, and mode. We connected that a long time ago, medium, median, but just again, the logical difference, right? Mean, average, median, middle, mode, most. Right? What is average to middle? Why is this pairing thing, why has that gone on? But mean is average, words have meaning, sensorality is virgality. But the speed of light is the radiation limit. And so temperature radiates as evidenced by heat waves. You turn on your grill, the propane's burning, and you can see ripples, right? What is that? And so trying to pair the right intuition to the right words. Yeah. A fraction is a ratio. What else do I want to say about temperature? Because again, like, what is a heat wave? When you're looking at that stove and it's just moving, what is moving? What does that affect? Why does that happen? Because you have, again, light waves, gravitational waves. It's just some sort of radiation limit. So it's all the same. And then you can visually see that one. Like, you don't have to have some extreme conditions. And it's, fracticality encompasses all of these physical properties being emergent and discernible to a certain limit at any scale, and the limit scale as well. But a fraction is a ratio. Again, that's just comparing two independent systems, and those systems have a minimum component of 2, and that's stability, charge, to magnetism. Yeah, so again, that just makes a lot of intuitive sense that magnetism is the stable dynamic of charge. Dynamic of 2 has periodicity, and then internally, again, that dynamic, and I want to think of, again, spin, it has a period to it, and so that's why things synchronize, that's why things can synchronize. Fundamentally, that's what the ringing in your ear is. And so, again, those are the the ringing, the frequency, and periodicity produces frequency, whether you're talking about light or whether you're talking about just any periodicity is referenced by frequency. Those frequencies differentiate, right? Are we on the same wavelength? And there's your dichotomy with de Broglie wavelengths. But bonds are connections. That was another big thing, is we have independent systems, but what makes one system is bonding, sharing of electrons. Because most of all physical systems have gaps in them, and a bond is the word that connects the physics to the logic. Bonds are connections. Mass is set, right? Just literally stating the conservation of mass. Direction versus dimension. And there's one tension path. There's one equilibrium. There's many things all trying to be the most efficient. And so, again, linguistically, I'm not going to point that out, but dimension now, and for a while, intuitively, hasn't really made sense to me. Again, things come in pairs, up, down, left, right, forward, backward. 3 pairs, but it's really, again, n plus 1 elements to describe n elements. But direction, right? There's always the stability of direction. It's always forward or backward, right? Because up or down is always forward. It's always up, down, forward, backward, left, right. It's always, you're bounded between 2 things logically. And so that's kind of like the geometric dichotomisticality. Just 2 points, 1 line, and it can't form a closed polygon. And then the most stable shape you have is a triangle, or not the most stable shape, but the first closed polygon you have is a triangle, and the most stable shape is a sphere. And then you get the whole, you can't square a circle. We went through all of that stuff. But logically, magnet, magnitude. Sensorality is magneticality. Just pairing our variable to our, again, out of all of this talking, what is a magnet? That's kind of where I think I'm at. But sensorality is empirical. Empiricality is evident. Existence is empirical. Empiricality is visceral. Viscerality sensates. It's another word logically, experientially, that everyone seems to say correctly, and it's still kind of like, what is it? Viscerality. It was a very visceral experience. It was like sensorious, sensational. It was vivid, vibrant. I don't know. Again, overall, the whole thing we're still trying to do is just find the stabilizing syllability. That's independent of me. I'm just trying to provide you any insight I can, especially at these endings or completions or whatever the fuck this is. You get a lot more insight into the phase changes, the more things that are directly consequential from the inferred logic. And so, right, we call this derivation, right? We went through like the orders, why that is, but then still intuitively, I can see why pushback. You say, why isn't integration first? Why aren't you saying you're putting a bunch of little pieces together? But we're making differentiations, right? And differentiation is derivation. And so that's why it's kind of like first, but you're separating frequency. And so again, both light and mass is like all just a stabilized frequency. And that's what vibration is. But viscerality, it's just people say everyone uses it properly and it's so visceral. It's just like, what the fuck does that mean? But viscerality sensates. But why then is the proton bigger than the electron? Does it matter? Because they both have one unit of charge. And so I just want to say it's a tighter dynamic. Like again, if you're spinning and then you're just spinning, you have an ice skater and they just tuck their legs in and they're just taking up less space, but they have the same. I think that's why the self-evident fact of proving charge is fundamental is that it is the way it is, that one positive, one negative, one electron, one proton. If charge wasn't fundamental, you would have, I think, more positive charge with more proton, like the proton being bigger. And so I think just the size of the proton and the electron being different, but still the conservation of charge existing proves charge fundamental. So I think we've made some progress on charge there. But again, it's just the magnet part that stabilized. The polarity of magnetism is from some sort of stabilized internal dynamic of charge. I'm gonna put that as almost as like a super theorem, ? Probably. But certainly the intuition should give somebody something. But electric charge, magnetic field. So you can say an electric field, but that makes logic. I'm pulling out my logic assertions here. Electric is to charge, magnetic is to field. Again, field is definitely this emergent thing from a bunch of independent things moving around. Charge, why do we need to put electric in there? What is electric? Electricity is moving charge, so that seems redundant to me. Electric charge. Electricity is moving charge. And a moving charge induces a magnetic field. Polarity attracts or repulses. And so now again, gravity is more of this linguistic form of vibration with a GRA in front of it, and polarity is the thing that attracts or repulses because charge is fundamental. And so a magnet is stabilized polarity. Polarity is discrepancy. Discrepancy is difference. And now directly linguistically, right, we said what is age? Age is just a number, so what is range? What is range to charge? Obviously, super fundamental, applicable math word, super fundamental physics thing. And then linguistically, the consonants is directly what is iterated. So again, range, we talked about that extensively last time. Charge, we just talked about that pretty well. Feeling good about that. But difference produces censorship. So now censorship that's what this C. And again, chronologically, C comes before S. But then both the C is the stabilized one, and the S is, again, just some sort of like iteration thing. And you see that evidently throughout both England English, American English, French, Spanish, like ciencia, like science in Spanish. It's just the C or the S, what's changing. And so that's some sort of like placeholder, but there's just some element or some sequence of letters that is stabilized, that is set in the past, that will never change, that is as 1 + 1 = 2 with letters. And so what is range to charge? Posing the question to pose it. Oh, but censorship. Like physically, like censorship starts with a C, C comes before S. Senality with a C, with toality. But again, how do magnets censor? How does charge censor? But differing censors. A cap is a censor. Censorality is no cap. Capless is censorless. Senseless is no sense. That makes no sense. And then the sense is some sort of, again, resonance, consistency of vibration. Sensorality is senseless. Less is the opposite of more. And so in morality, right, more or less, like greater sign, equal sign, or less sign. So again, that was such a simple result, but it's still so poignant, and that one is huge, right? When you go into math class and the little Pac-Man looking thing, the logical consistency to that symbol is more or less, not greater or less. So that's another one that's just like a massive, tremendously huge result. But I've proven that one a ton of times. All of the stuff I've proven, but some of the stuff on the charge definitely feels more poignant. But so then now again, this bounding, this generality, these four languages, we demonstrated the bound. I remember saying that very poignantly earlier today. But again, how do we pair like prefix and suffix to more or less, or just some sort of bounding where language is completely general, and you can have this completeness? And how do, again, that the ing to the e, right? What's the difference between ing and e? The sound to the linguistic representation. But it could be some sort of bounding, again, of less is more, because again, inversion, nothing is the opposite of the universe. Nothing is the opposite of everything. So now we're in this open dynamic, but we have a physical bound of 2. And so you have natural opposition. And so we went through the infinity very well last time. Universality is university, right? People go to school, people go to college, people go to university. Normalizing is soralizing. Sensorality is soralizing. Sensorality is moralizing, right? Right, that was very demoralizing. Well, sensorality is very not that. It's very moralizing, encouraging, exciting, like showing you the logic. Again, just trying to get you as much intuition as I can because it feels very poignant. But it really doesn't, like the derivation, it's always there. Like it's just always there's just so much of it. But again, trying to give you as much insight as I can. Again, my rights continue to be violated. Just a little bit of money. You guys have my accounts. Just put a little bit in there. That's all I ask for. Anyway, that's what I got for you. Thank you for watching. See you on the next one.